Okay, we're looking at percent of increase or decrease. And you actually watch this every week if you watch the show The Biggest Loser. All right, let's take a short look at a clip.
You lost 12 pounds this week for a total percentage weight loss of 3.43%.
See, that's their percentage of weight loss. So how do they get those numbers?
I'm falling lower and lower and lower on that scale. And I'm starting to freak out. Jordan is next on the scale. Jordan, when you first started with The Biggest Loser, you weighed 323 pounds. Your current weight is.
All right, if we backed it up a bit, we saw that his weight was 233, and they're weighing him now to see how much weight he's lost. So right there, he weighs 233. They weighed him now, he weighs 227, so he lost 6 pounds.
I can't be mad at a 6. I really can't. I'm just really hoping that's enough to stay.
Congratulations, Jordan. Thank you. Jordan, you are now in danger of falling below the red line.
So Jordan had, if we back that up a little bit, .58%. How'd they get that? Well, what they did is to find a percent increase or decrease, you always look at the previous starting point. So that's why we looked at 233. And then he lost 6 pounds. So if we were to take out a calculator and do that math, we would see 6 divided by 233. Look at that, 0.257. 0.257. And then The Biggest Loser turned it into a percent by moving the decimal over 1, 2, and then they probably rounded to get that percentage. Now remember, this goes back to part over total equals percent. So his total weight was 233. He lost 6 parts of that, so it came down to a percentage of 2.58%. So it's our percent of increase or decrease. It's looking just like our percent formula that we learned the other day. Macy's, yes, the store, buys coats for $30 and then sells them for $80. What is the percent markup on the price of the coat? See, that's how you make money. You buy something for little and hopefully later you sell it for more. So let's get our heads straight and let's do our part over total equals percent. Well, which one's our total? $30 or $80? Well, remember back here we said we always go from a previous starting point. So Macy's started with the $30. Then they marked up. They didn't mark up $80. They actually marked up $50. And now we're going to divide that out to find our percentage of markup. 50 divided by 30, 1.666 repeating, but I have to move that into a decimal. So there is 167% roughly, if I move that over 2 places and then round, markup. Yes, over 100%. And it makes sense. If the jacket was $30 to start with, 100% markup would mean you double the price. And that would only bring it to $60, but we see we're at $80. So yes, 167 does make sense. In 1967, a Super Bowl ad commercial that was 30 seconds long cost $40,000. In the year 2000, a 30-second commercial cost $1.8 million. Wow. What's the percentage of change in the total cost of a commercial? Well, once again, this is like The Biggest Loser. We're going to start at 40,000. That's our total. And again, just like the Macy's problem, it went up in price. In fact, how much did it go up in price? Well, 1,800,000 minus 40,000 equals 1,760,000. Wow, that percentage is going to be huge. So let's take that and divide it by 40,000, and we get 44. So it was a 44% increase. No, we still have to make that into a decimal. We have to move that 2 places. It was a 4,400% increase. So yes, you can realize that percentages can go over 100. All right. Agronomists are studying how quickly the population of an invasive species of beetle will increase in a controlled farm setting. They calculate the populations increasing at a steady rate of 6% per week. At the beginning of the week, the beetles were 350. How many are there at the end of 5 weeks? Well, there's a couple ways to do this. We could do it the long way. 350, we could multiply it by 0.06, because that's how much it goes up every week, and find out that that made 21 more beetles. We could add the 21 onto that. Then we'd have to multiply that by 0.6. We have to take that number, add it on to 371, and then multiply that by 0.06. And wow, how many times do we have to do that? We have to do that for 5 weeks. Well, this is the long way. Let's go back to our exponential function one. Whoops. This one makes a lot more sense to do because it's like what we've been doing. Remember this exponential? We have a starting point. We started with 350 beetles. We have a time, 5 weeks. And our base, if we remember, is 1.06 because I'm always having the original 100% population and 6% more. That way is much easier to figure out. 350 times 1.06 to the fifth, 468.37. Now we have to use common knowledge here. 468, can we have 0.37 beetles? No. So in this case, it would be 468 beetles because we didn't have enough to make a full beetle. So this is how we do a percent of increase when there are multiple rounds. And it's nothing more than we learned in the last section. All right, the enrollment of students at a school is decreasing at a constant rate of 5%. The population is 2,300. What will it be in 3 years? Well, once again, this is a multiple. It wants us to look over time. So we're not going to do our simple percent of increase or decrease. We're going to do our formula again. Our starting point is 2,300 students. But careful, 95% is what remains. Remember, this is always what remains. So if we're decreasing by 5%, we have 95% remaining each year. And then we want to do this 3 times. Back to the old calculator. And again, we don't have enough here to make a full student. So there's 1,971. You can't have 0.96 of a student. And the last one. Carolyn, an employee of Hollister, bought a sweater originally priced for $55, and she got it for $38.50 after her employee discount. What's the percent off of this employee discount? Well, this is not a multiple step because she didn't receive multiple discounts. She only received one discount. So, the total is $55. We're going to go back and look at this as a part over total equals percent. But what is the part? Is the part $38.50? No, because they asked for the discount. She didn't discount it $38.50. She discounted it 55 minus $38.50. She discounted it $16.50. So she got $16.50. That's the part that she got off of 55. So she received a 30% discount. Now, you could have done it the other way if you really understood percentages. You could have said 38.50 is the part she's paying, divided by 55, and that would have gotten you 0.70. But 0.70 is 70%. That's not the discount. That's what she is paying 70% of the original cost. Therefore, she's getting 30% off. And that's what the question asked. What was the discount?